Welcome back. This is Neo Trinity, an 8 HP modulation powerhouse from Bastl Instruments. It gives you 6 outputs which can be all sorts of different forms of modulation. LFOs, envelopes, quantizers, or even triggers for drums. In this video, we're going to go through how it works, understand the user interface. I'm going to show you some patch examples that highlight the flexibility and power of Trinity. If you have any questions or comments, please leave them down below in the comment section. I love hearing from people and try to answer everybody's questions. Just to add that Bastl sent me Neo Trinity to experiment with and do this demo video, but I don't get paid for these videos. This channel and everything I do here is a hobby. You've got 6 outputs, A, B, C, D, E, and F, and they're in this L shape across the top here. And then you've got these 6 buttons which allow you to select each one. Each output, you can see here the illuminated LEDs, can be in one of 3 modes. It can be an LFO mode, you press the mode button and it becomes an envelope generator, or a CV recorder modulator. Now the shift button gives you access to other functions, and you're going to be using this button a lot. It gives you access to these highlighted controls here. For example, if I press shift, I can change what type of wave shape is being generated by the output A. So we have a ramp down, triangle wave, ramp up, we have a pulse wave, and we have a stepped random, and stepped random with slew. In fact, the F parameter here, if you turn it on and off, it's a toggle. So for example, if I set the wave shape by pressing shift and B to triangle, and then turn on F, the triangle turns into a sine wave. Similarly, if I set it to a ramp down and then press F to turn it on, we get a more rounded envelope. Channels E and F are a little bit special because they have these 2 inputs, input E and input F, which can be used to CV modulate the parameters on the channel, for example, the rate of the LFO, or it can generate different triggers or envelope shapes. And there's also this meta-in input which can be mapped to different parameters on all of the channels. So you could have one input here to, for example, reduce the amplitude of envelopes or LFOs across all of the channels at the same time. Yeah, I've patched up a very straightforward patch using Pizza here, just into Ikarie and then into the mixer. And for example, we can take a look at now this triangle LFO. We could patch it into, for example, FM index here on Pizza. And as you'd expect, an LFO is just going to modulate. And we could, of course, go ahead and change the shape of the LFO. To sync the LFO to an external clock, I press and hold A here, and I can turn it on and off using this button here, the clock button. Okay, now that we have it patched up and we've got the clock in, let's just bring up the audio, and obviously we're just hearing the LFO free running here. And now we're going to sync it to the clock. Now we can do a couple of different things here with the rate knob. So as we're doing this, we can adjust, for example, the frequency of the LFO. And in this case, it's down ramp, or we could set it to be up ramp. But what's more fun for things like this, for example, is stepped random. And again, I could set this to be unipolar. Right now it's bipolar. And I can go back there to unipolar. One of the nice things you can do is you can mute an LFO. So press mute, press A, and it goes back to 0. Mute an A again, and it's unmuted. Trinity has got 2, I'd call them automation lanes. There's a modulation or automation lane for the record button and another one for generating triggers. So one way to look at this, if I go back to LFO mode here, we're looking at the stepped random. We can hear it there. I can adjust the speed, obviously by turning. But watch what happens if I hold record and do that. Now you see there it's recorded my knob movement. And so I'm able to record knob movements, which in the case of an LFO, the knob adjusts the frequency of the LFO that's playing. Say I wanted to clear out the automation I've recorded, double tap on record, and you'll see the red light goes off, and now we're back to just free running against either the clock internally or the clock externally. Let's put it into envelope mode. And in envelope mode, we record in triggers. So you can record triggers into the, I wouldn't call it a sequencer, it's like an automation lane. And you do that by pressing record and tapping on shift. So let's do that again. And there you see on the oscilloscope, I'm recording in different triggers, and now they're playing back as the automation plays. And now the knob, in the case of an envelope, adjusts the decay time. Of course, this is set to decay mode. We can also set it to ramp up mode. Now let's look at how we can use the NEO Trinity to actually generate envelopes that you could send into a VCA, for example. Now to do this, you can only use channels E and F because they have inputs E and input F, so this is where you can send the trigger in. Though if you were to use the meta input channel, you would end up triggering these other channels, but then you lose control of other things using meta in. So I tend to keep that one for modulation, use these guys for your envelopes. Let's just patch output E here into the VCA of Ikarie. And we're going to set channel E, we're going to go over here onto channel E, we're going to set it to envelope mode, which is what we were using previously. But now we need to configure input E. And the inputs are configured by pressing and holding the channel button and then using this mode button to cycle through different LED combinations here, which correspond to different ways that that voltage or trigger is interpreted. So for this particular case, we want it on env trigger, envelope trigger mode. That means a trigger coming in here to E is going to generate an envelope defined by, of course, the parameters here. I've just pulled out the patch cable and I'll just patch in the oscilloscope so we can actually see what's going on. So we'll send in a gate from the Oxy1 sequencer here. And then when I hit play, we can actually see the envelope being generated. And I can adjust the length of the decay. Indeed, I could change it if I wanted to ramp up envelope, which would be kind of weird. So there's our, and I can patch in a pulp octave. A little bit of reverb there. You can record modulation of the envelope length by pressing and holding record. And now it'll play that back. So you're still able to record and use modulation to kind of humanize those envelopes a little bit. Let's try another envelope. This time we'll patch it into maybe the FM index. We'll use the pink channel, so channel 2 here on the oscilloscope. So I'll go to envelope output F, go to channel F, so I press F to select it. We go into envelope mode, press and hold F, so I cycle to the envelope trigger mode set, which means input F is now going to accept a trigger. We'll patch the envelope into FM index here on Ikarie, on Pizza. And we'll send in a trigger from, I don't know, we'll send it in from Steppy over here, just because I have a few of them programmed in. These are both clock syncs, because if I press and hold F, we can see the sync light is on. A little bit of a kick drum there. You know, I want to add a little bit of modulation here on the shape. Let's do that using the A over here, which I'm going to put into LFO mode. It's in stepped mode. I think I remember. Yeah, we have it in stepped mode there. Shift will show you. Oh yeah, see? Look at this. We're going places with this. Patch in a hi-hat here just to have a little bit of a groove going. Well, I've been talking about clocking and clocked and unclocked LFOs. So let's explore how the clocking works in Trinity, because understanding this actually opens up some very interesting patching ideas. We'll first start with just looking at the internal clock and how you can adjust the clock rate. So I'm just going to patch the blue channel here on my oscilloscope, which is channel 3, to clock out, and we can see our clock is running, the internal clock is running. Now, to change the clock settings, we go and press clock. Now, straight away you notice that all of the other lights have gone out and this sync light is on. So that's how we know we're now in clock setting mode. And we're able to adjust the rate of the internal clock by just turning the rate knob here. It can go all the way down to about 35 beats per minute and all the way up to about 300, as you see there on the oscilloscope. But what if we want to synchronize our clock to an external clock? So we'll patch in the external clock here on the yellow channel, channel 1 from the Oxy 1. I'm going to patch it into clock 1. Now notice straight away, of course, the internal clock stops. And that's because if anything is plugged into clock in, it waits for the clock pulses to come in before running the internal clock divider. So now it's switched into clock divider mode. I'm just going to start my clock now on the Oxy 1, and on the yellow trace there on the middle of the screen, you see the clock pulses ticking away from the Oxy 1. And now the clock mode, which we can go into over here, allows us to set clock dividers. So first of all, the rate knob allows us to choose a different clock divider. We can go up to 1 external pulse generates 4 internal pulses, and all the way down to a divide by 8. But notice that the clock pulses aren't quite lining up exactly. And why is that? But there's an overall multiplier divider also applied. So say you wanted to really slow the clock down, you can press in clock mode, Shift and A, for example. And what that will do is divide by 8. So 8 times divider is then applied to whatever this rate knob is set to. And if I press Shift B, again, I'm in clock mode, Shift B, it's now divide by 4. So you see my internal clock is now going a little faster. Shift C, divide by 2. Shift D is a 1-to-1. Now, we've talked a little bit about me recording in triggers to generate envelopes or retrigger LFOs. But what about if we use those triggers to trigger drums? Well, it turns out Neo Trinity has a series of pre-programmed drum patterns, fill patterns, and Euclidean sequences that you can generate by setting up some special modes. So what I've done is I've patched A, B, C, and D outputs here into the trigger outputs for the fire module here, so that I can actually trigger some drums, and we'll hear them here on the mixer. Each of A, B, C, and D are now in envelope mode, so they'll generate a kind of a plucky trigger envelope, which will trigger once it passes a threshold voltage over here. Now, to turn these into triggers, we could, of course, program in triggers directly manually. But if we want to do it using the generated or pre-stored trigger sequences, we press record, we keep holding it and press shift. Now I'm going to select channel A for this. I press record, press shift, and there's different banks of triggers, A, B, C, and D. Bank A is kick drum triggers, bank B is snare drum triggers, bank C is hi-hat triggers, D is a clock divider derived trigger, E is Euclidean triggers. Output A to be my kick drum. So I do record, shift, I'm going to select bank A. The rate knob now selects which of the different patterns which are defined in the manual, and you see them on the screen. Okay, now I've cleared out all of the triggers that I had recorded in, and I've got the external clock coming in from Oxy 1 here. So I press record, shift, and now I can choose. And there's our 4 on the floor. Now, B is on the snare, so I'm going to go. That's, I think, the snare bank there. We'll choose that one. And D is on the hi-hat. So for D, I'm going to use the Euclidean mode. Let's press E there for Euclidean. I select the number of triggers. And it's the number of steps over the overall automation length. So in this case, I've set my automation length to 16. Now, of course, I can still use the other LFOs, or in this case, E is going to be set to envelope modes because I want to actually use it to generate an envelope. And I've got F on sept random mode. So I might patch that into, say, wave shape here. Actually, FM index. this has just been generated by Trinity. And if I didn't have an external clock coming in here, it would be clocked internally. So that's really pretty cool, because those triggers can also be applied to things like envelopes for other modulation. So don't think of them as just drum triggers. Now, we've talked about the automation lanes, but how do you set the length of the automation lanes? Well, to do that, you press and hold record and press A or B or C or D or E or F. 2, 4, 8, 16. I usually leave the automation length on 16 there, which would be D. And that will also help then for Euclidean triggers, because that 16 step sequence is what we're going to use. Let's take a look at a couple of patch examples building on some of the things I covered already in the video. And I want to show you how you can use Trinity as a quantizer. And that means you can actually use that built-in quantizer to quantize external voltages. So let's give that a go. I've set up channel E as an envelope generator, so if you look, it's in envelope mode, just like we talked about previously. So I'm going to use that to trigger my VCA over here for pizza, and I'll program in a few. There we go, a few triggers are now programmed in. Good stuff, off we go. Now, how do we actually set up a quantizer? Well, to do that, let's use channel F. And channel F is set to CV mode. And for channel F, I just press again and hold the F button, and we can see that the input F is now configured in plus mode, which is the LFO and envelope lights are on. So we know that it is now going to be taking voltage in there. So I can now pass a voltage in to channel F, and it'll quantize it. And I have it, if we just press shift, we can see the D light is illuminated, which means the quantizer is on, as we showed previously. And all of these three are off, so it's in the minor scale. So quantize to minor scale. I'd like to trigger the quantizer, and for that we're going to use the meta in. And so for channel F, if we take a look, we're here on channel F. I press shift and mode. Now this lets me configure the way meta in behaves. And if I press shift and hold mode, it turns it off completely. But I'm just going to turn it on to CV, sample and hold. Meta in is an additional input that can be mapped onto any of the channels, or one or two of them, or all of them if you wish. So I have it turned off on all of the other channels, but on channel F, it's in sample and hold mode, which means a trigger coming here will trigger the quantizer to quantize a voltage. Now when I hit play, I'm triggering the envelope, of course, from Steppy and the quantization off a separate sequencer. Okay, let's take a look at a couple more patch ideas. A variation on that previous patch is to use, say, the two channels E and F as complements to each other, and we can create a stepped LFO for that. So let's go over to channel F, and now we're going to set it into LFO mode. So we'll just go back to LFO mode there, and we'll just set it to, say, a triangle LFO. And if we just take a look at channel F here on the output, it's exactly what you'd expect. We've got a nice triangle LFO going on. But what we want to do is we want to have that be triggered. We want the LFO to be triggered versus just free running. Like what we'll do on channel F is we'll press and hold F and set the mode so that CV sample and hold light is lit. And now it's a triggered LFO. Now with this trigger mode enabled, we're able to send triggers in to quantize the LFO. So for example, I could send it in triggers from Steppy here. And you see now on the scope, we've got a quantized output. We could patch that into FM index over here. And then when we take a listen. And you can play around with the relative frequency. You could also, of course, clock it from the internal clock out. And now there you see the sine wave or the triangle wave, I should say, is pretty well accurately represented. But then by slowing down the LFO, you can get to some very interesting stepped values. Now, up till now, the LFOs have been running at their full range. For example, if we take a look here at, again, we'll use channel F as the example. It's going the full whack from plus or minus 5 volts to each extreme. So how would we attenuate down that amplitude, and could we put that under CV control? And the answer is, of course, yes. So let's go in, and again, you're noticing it's all about changing the modes of these inputs. So we press and hold F, and this time we want to change the mode to be the LFO VCA light on. So let's just cycle through till that light is on its own. And now input F allows us to change the amplitude of the LFO signal coming out of channel F. And of course, you can put that under control from another LFO. So let's use channel E. We'll set channel E up as a sample and hold here, and we will make it an LFO as well. And it's happily running away. And so I can patch the output of channel E into the input of channel F. And now you notice that the amplitude of channel F is changing based on the values from channel E. Likewise, if I didn't want to do it that way and I wanted it more manual, I could say patch the output of my control here. This time it's gliss. And as I reduce the values down, you can see the amplitude of the LFO changes. So I could put that under manual control. So for example, if I was using this to modulate a filter, I'll put it into full per octave here in Ikarie. That's a bit extreme, isn't it? Now you can go up to great extremes, and then you might want to bring it back down. Another trick we can do is we can create a kind of a quadrature LFO or detuned LFO style effect here. The LFOs will all be synced to the clock, but they'll ever so slightly be out of sync with each other. But more importantly, we'll map the meta in parameter to different effects on each of them, so that changing the input value here changes each LFO differently, creating a lot more movement. So we've got 4 LFOs all running, and I'll just set LFO A is clock synced, LFO B is clock synced, C and D. But now what we want to do is change how the meta in is mapped for each of them. And to do that, we're going to say channel A, we do shift mode, and we will change that to be regular attenuverted. Channel B, slightly different. Go to channel C, mode, and channel D, mode, shift mode. And so I can now patch the output of gliss into meta in, and it will change how each of these LFOs behave. See, they're going faster now. They're all slowing down. Now let's look at using NEO TRINITY as an oscillator. And because we have quantizers and envelope generators built in, it actually becomes almost a full synthesizer voice. So what I've done is gone ahead and set channel F to be in LFO mode. Now, right now, that obviously is just generating a DC offset, so it's not going to be any use to us. But what we want to do is map the input F to be in normal mode, or plus mode as it's called, because then it will adjust the rate of the LFO, in other words, the frequency of the oscillator, based on the voltage there. Great. Now we have a volt per octave input for our oscillator, if you will. We like to quantize that, so let's use the quantizer on channel E. We set it to CV mode, which is that mode we're always using for CV processing. And if I press shift, you can see I have D light illuminated, so the quantizer is on, and A, B, and C are off because I'm in the minor scale. Now voltages on the E channel are quantized into the minor scale, so we can patch that into input F. All right, we're getting somewhere now. We listen. We could go into channel E. And so adjust the frequency of the oscillator. And of course, I can change the wave shape. That's a ramp down. There's triangle. There's pulse. I'll leave it on ramp down for now. Now, how about creating envelopes? Where would I get the envelopes from? Well, we know we have an envelope generator. So let's go into channel D. You can see here it's an envelope mode. And what I need to do is map the meta in for channel F to be a VCA. So I go back to channel F, I selected it here, then we press shift and mode, and we see it's in LFO VCA mode. So meta in is now mapped for channel F onto being a VCA, which means an envelope there will sound out the oscillator. So let's create an envelope, and we'll do that on channel D. So I'm just going to patch the output of channel D into that meta in. And of course, I could patch in an external CV into this channel E quantizer. We can also use Neo Trinity in a much simpler fashion to just create and record melodies and trigger sequences. So I've set channel E up here as an envelope generator and patched that into the VCA, so I can patch in some clock synced envelopes here. And channel F I've set into CV mode. And in CV mode, I have it in VCA mode, so I could actually gate it there. But more importantly, it's going to allow me to quantize, because I have the quantizer turned on and it's in minor scale again. So knob turns here can be now recorded. So we could actually do this, for example. We could first of all go into channel E and record in a rhythm. And then go over here onto channel F, press and hold record. And of course, we can use a little bit of stepped modulation from elsewhere here. So into the FM index. Another LFO here, maybe into the wave shape. And of course, all of this is coming straight out of Neo Trinity. We're getting the envelopes being generated here in channel E. We're recording the note sequence there, quantized on channel F, modulating way over here, and it's all in sync with the master clock, so my drums and all are in sync. If we take the previous patch I just showed you, the envelopes were all at a consistent amplitude, so there wasn't very much changing or variation in the sound. But of course, you can change that. You can humanize those envelopes by varying the amplitude of them by mapping input E here. So let's just go down to channel E. You see, of course, it's in envelope mode. And if I press and hold E, the input E is mapped onto VCA mode. So this means that now the amplitude of those envelopes is controlled using input E here. So if we just start the turn off the drum so we hear it, and now we start the sequencer, and as I bring down the voltage, the envelopes are quieter, and of course so I can adjust and humanize my envelopes, perhaps using an external step random, or another one, of course, from one of the other channels here on Neo Trinity. We've been looking at some very esoteric patches, but let's look at a few very simple things we can do, like attenuverting and offsetting LFOs. And for this, we can use the fact that you can map different types of input controls onto the inputs for E and F. We'll set input F, it's in CV mode. And what I want to do is just take the output of it here, and we'll just take a look at it on the ping trace on the oscilloscope. So nothing particularly interesting. There's the offset amount. We'll just set that back to 0 there. But what I want to do with this is set the input mode for input F. This is positive attenuversion. So what I'm going to do is take this bipolar LFO coming out of Eben LFO there, which you see on the yellow trace over on Ornament in Crime. If I patch that into input F now, you can see we get a attenuverted and also offset version of it coming out on the pink trace. And if I turn the knob this way, I can shift it up until we hit the voltage limit, and this way I can shift it back down. If I wanted to invert that on input F, press and hold F and go to inverted mode, and now you notice we're getting an inverted version of the same waveform. The last thing I want to talk about is how you can save all these settings. We've been going through quite a few different kind of configurations for LFOs and envelopes and everything. And wouldn't it be nice if we could save some of our favorites, maybe for performance or for recalling later? Well, you can save up to 6 banks, which are all of the settings for each of the 6 channels. Bank is the button that allows you to load. So by pressing bank A through F, you load one of the 6 banks. Shift bank will then save that. So we could save these settings here into A, and then we could press bank and say B, and we'd load up totally different settings. You see the lights have changed. Bank and C, and again, totally different, and then bank at A, and we're back to what we had originally. Very, very handy for saving some of your favorites. So if you had envelopes configured or sequencers programmed in, this will save all of that. That wraps up the video on Neo Trinity, and I had a lot of fun playing with this and really kind of getting to learn it and figure out how to use it in different patches. And I can see myself really using this in combination with like Pizza, Ikarie, Bastl, and a few others, because whenever you need those kind of modulation sources, it has them right there to hand, and all of the controls are right on the surface. So thank you as always for watching. I always appreciate everyone's comments and questions, and feel free to leave yours down below if you want to know more about this module or indeed any of the other ones on my channel. Always happy to hear from people, and I try to answer everyone's question. Don't forget to subscribe if you want to stay up to date with future videos. Thanks for watching.